today we're going to continue solving quadratic or polynomial equations. Yesterday we did the graphing method. Today we're going to do it by factoring and solving. And this will be useful especially whenever we have ones that are in cubic form. So these formulas need to be memorized. I didn't have time in homeroom today, but I will try to look for some math songs or something that could help you memorize it. The formulas are almost identical. The only thing that differs is the symbols. So the a cubed plus b cubed formula starts out with a plus b. So you can see that the symbol of in the original is the symbol of the first polynomial that you have there, the binomial, I guess I should say. So it's a plus b. And then in the second one, it's a squared minus ab plus b squared. So this one goes plus minus plus. I don't know if that's something you can memorize, but something to note about it. The second one is a subtraction, a cubed minus b cubed. So an example of that would be this, x cubed minus 125. 125 is a perfect cube, it's 5 cubed. So then you would factor that down into a minus b times the quantity a squared plus ab plus b squared. So it goes minus plus plus. So I don't know if you just want to remember the positive one alternates, positive, negative, positive, and then the negative one starts out negative and becomes positive, and I don't have really a logical reason or a trick to memorize it, just it's memorized. But since I forgot to give you this sheet, you might want to jot down what your perfect cubes are. And I have even more of them, but I feel like well, let's do 7 cubed too, just to be safe. So we know our perfect squares, 1, 4, 9, 16, 25, 36, etc. You can find your perfect cubes by cubing the counting numbers. So 1 cubed, 1 times 1 times 1 is still 1. What would 2 cubed be? Sam? 8. What would 3 cubed be? Garrett? 27. Biggest mistake I see is 9 for this one. You guys are just saying 3 times 3 by accident. Make sure you think it's 9. How about 4 cubed? 4 times 4 times 4. Awesome? 64. 5 cubed, I just told you, is 125. 5 times 5 times 5. How about 6 cubed? Sam? 216. And then 7 cubed will be 343. There are obviously more. You can do 8 cubed, 9 cubed, 10 cubed, which will be 1,000. But these are the most often, because I try not to give you too big of numbers. These are the most often ones you're going to see. So you might want to familiarize yourself with them, just so that when you see them, you know they're a perfect cube. All right, so when you're factoring, and these set of examples just ask us to factor, not solve. So when you factor, you leave it in parentheses. Okay, you don't actually find the answers, you're just factoring the sum or the difference of cubes. So when you're using the formula, the first thing you want to do is identify what is a and b. So a, in this instance, is 1x. This is really 1x cubed minus 5 cubed, right? 1 times 1 times 1 is 1, x times x times x is x cubed, 5 times 5 times 5 is 125. So what this is telling me is that my a value is 1x, my b value is 5. And then you're going to substitute into the formula for the sum or difference of cubes. Since this one is a subtraction, we're going to use the difference of cubes formula, okay, which is a minus b times a squared plus ab plus b squared. So it's the minus plus plus one. And then all we're going to do is we're going to plug in the numbers and simplify. Okay, so we'll have 1x minus 5, or just x minus 5, a minus b. Now be careful, when you square a, you have to square the 1 and square the x, which will still get us 1x squared plus a times b would be to multiply 1x times 5, which is 5x, plus b squared, which would be to square 5, which is 25. So all I've done is taken each of these values and substituted them into my formula. This is your final answer for factoring. I will tell you that this is not going to be factorable. So don't waste your time trying to factor. I see a couple confused looks. They're questioning. Okay, the next one. Again, think about what cubed gets you 8. 2 cubed. So this is really 2x quantity cubed minus 1 cubed, which based on my formula, that's my a and my b. So a would be 2x and b would be 1. And then we use the formula. This one's also the difference of cubes, so we're going to use the same formula we did last time. A cubed minus b cubed equals the quantity a minus b times the quantity a squared plus ab plus b squared. The more you do these factoring problems, the faster you won't have to write out the formula every time. You'll just kind of memorize it, but while we're starting. And then substitute in your values. So a is 2x minus b, which is 1. Make sure you don't think b is a negative 1, too. That's one thing some students will do, and they'll be like minus a negative 1. So you do just want to think of this, because the formula has a subtraction, so you're just taking the symbol. Times the quantity. Now this is where I'll see you make a mistake. A lot of people will put 2x squared here. If you're squaring a, you have to square the 2 and the x. So this should be 4x squared. Plus a times b, 2x times 1 is 2x, plus b squared, 1 squared is just 1. And that's our answer. Last one is the sum of cubes formula. Oh, sorry, Abby?
So you would like square the number, but then you'd still write the square because of the x?
Because I squared the 2 and I squared the x. So it's almost like you're doing this, Abby. When you square 2x, you're taking 2x times itself, which would be 4, and x times x is x squared.
So then if we were to try to factor, you wouldn't put the square, it would just be the x.
If you were to try and factor this, is that what you're saying? Then you would do like 4x and x, or 2x and 2x, or whatever. But I'm going to tell you that that second one is not going to be factorable.
Those students going on the academic league field trip, please report to the front lobby at this time.
And below, we're going to solve equations like this. We're going to have to use the quadratic formula to solve this, back from chapter 5, because it's not going to be factorable. So they never are. All right, the next one. What cubed gets me 27x cubed? Garrett? 3 and x. Plus 5 cubed is 125. Now notice this one is the sum of cubes. So you're using the first formula. A cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. Plus minus plus. Then you sub in your values. So a is 3x, b is 5. So our first quantity would be 3x plus 5. Again, the most commonly missed part of this is, first of all, mixing up your signs. Second of all, right here. What would I put here? Sam? 9x squared. 3x times 3x is 9x squared. Minus AB, which would be 3x times 5, 15x, plus b squared, which would be 25. And that's our answer. All right, so what we're going to do below on the bottom of this paper is we're actually just going to solve these equations. So all we're going to do after this is instead of just factoring it, we'll actually see it set equal to 0, and we'll use the zero product property. We'll get 3 answers. So, when you're asked to solve, find all complex roots. Remember, complex includes imaginary roots. So these are ones your graphing calculator can't find for you. Not possible to find on the graphing calculator. Has to be done by hand. What we're going to do is we're going to, just like we did in chapter 5, get the polynomial in standard form, which means get it set equal to 0. You're going to factor. Identify what the values of A and B are, substitute them into your formula, which you have at the top of your notes. We're going to factor the trinomial into two binomials, or actually a binomial and a trinomial, and then we're going to use the quadratic formula, if necessary, to find all three answers. Okay, so this one is almost identical. Well, no, it's a combination of ones we have up top. So let's just go ahead and factor it first. We already have it set equal to 0. So this would be 2x cubed plus 5 cubed equals 0. So since this is a plus 1, I'm using the plus formula, okay, which is a plus b times the quantity a squared minus ab plus b squared. And I am going to still set this equal to 0. Plug in our values. So this would be 2x. Well, let's make a list. A equals 2x, b equals 5. So plug those in, 2x plus 5. Remember to square the 2 and the x here. So 4x squared minus 10x, 2x times 5, plus 25. So everyone make sure you have all of those numbers right before we move on. Okay. Now, we have to find 3 answers. One of them we can actually find, and I would just draw an arrow down here because all your answers are going to end up at the bottom, and I don't want you to lose this one. So this would be 2x plus 5 equals 0. Using your zero product property and just setting that equal to 0. Subtract 5 on both sides. Divide by 2. We'll get x equals negative 5/2 or negative 2.5. That's one of my 3 answers. Now, the other one, unfortunately, is not factorable. These never are. On the back, we'll see some that are factorable, but they're not the difference in sum of cubes. So if you have a difference or sum of cubes, this is not going to be factorable. So you have to use the quadratic formula. Which is, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Chapter 5. It's coming back to us. Now be careful that you don't mix up these a and b's with these a, b, and c's. There's problems. So a is 4. And I'm just going to come into this space. B is negative 10. And C is 25. Plug into your quadratic formula, simplify and solve. Remember, you want to simplify everything under your radical first. So do that whole part first and then square root it at the end. I'm still running out of space. Let's do this. And then you can either multiply these, 4 times 4, 16 times 25, or you could do 25 times 4, which is 100. 100 times negative 4 is minus 400. You can multiply them in a different order since multiplication is commutative. All over 8. Subtract under a radical. I'm going to get the square root of negative 300. And then we have to reduce the radical. First take out an I. So this would become I square roots of 300. What would I break 300 down into to reduce my radical? These are square. This is a square root, so perfect squares. Sam? Yes, break it into 100 and 3. And we solve our I. So the square root of 100 is 10. So now I have 10 plus or minus 10I square roots of 3 all over 8. The last thing that you can do is you can reduce the 10, and the 8. So remember, you can actually break this up to be 10 over 8 plus 10 over 8 if you prefer. But you have to divide each number by 8 since it's a big division. So this would become, dividing by 2, 5 over 4 plus or minus 5I square roots of 3 over 4. Or you can have one big fraction all over 4. Don't forget that this answer over here is also one of your answers. So just kind of draw an arrow. These are together, all 3 of them. This is 1 and 2, plus and minus, and 3. Okay. Let's do 5, which I'm going to have to run into, or do we want to, yeah, 5 has smaller numbers. So let's just skip 6. We'll do 5 since it's smaller numbers. So start off by factoring this. This is really 1x being cubed plus 2 cubed. We're going to use our sum formula, identifying that the a value that's being cubed is 1x, the b value is 2, and then we're using this formula. Yeah, normally you're not, once you get the hang of it, you won't be writing this formula every time. So that'll save you one line of work. So substitute in, we get x plus 2 times x squared minus 2x plus 4. Biggest mistake I also see is students forget about this 0. So that's why I always say, like, drop it down like to the bottom where all your answers are going to be written so you don't forget about it. We would get x plus 2 equals 0. Therefore, x equals negative 2. That's one of my answers. That's the easiest answer to find. Now the other one, this is not factorable. Numbers that multiply to 4 and add to negative 2 don't exist. That's why you have to use the quad formula. Here's my A, my B, and my C. So we should have positive 2, the opposite of B. B squared minus 4 is A. Let's see. And then our 2A. And then just clean that up. Chapter 6 problem with a Chapter 5 problem. So I warned you that here does get a bit challenging. Chapter 6 on. From here you have to simplify just like we did, so this would become I, break 12 in to be the square root of 4, square root of 3. So this would be 2 plus or minus 2I square roots of 3, technically all over 2. If you want, break it up as into each of them divided by 2. And so your final answer should be 1 plus or minus I square roots of 3. Or 1I square roots of 3. Okay. Why don't you guys, since you probably don't have room on your notebook, on your notes, why don't you actually go and do this problem on a piece of notebook paper that you have for your homework, and then we'll finish the notes tomorrow, because I can tell we're not going to finish them today, so it's not even worth it. Tomorrow's a practice day anyway, so it's fine. We can finish up the back. So I'm going to have to modify your homework then. Since we have a few minutes, see if you can complete number 6 from the notes, and then I'll pull up your homework and see which ones I can omit. So we're only going to do numbers 12 through 20 on the homework tonight. So 21 through 32 we'll do tomorrow.
Excuse the interruption. Would the following students please report to the nurse's office at the end of this period? Ariel Bonus, Bailey Bird, Lucas Barson, Caitlin Craig, Dylan Fife, Mason Fortunato, and Brandy Noble. Please report to the nurse's office at the end of the period.
Alright, the answer for the problems up on the board, and make sure that you jot down that tonight you're only going to do numbers 12 through 20.